Hi, this is Pradeep. Today we are demonstrating K-means clustering algorithm in Spark on Cloudera Hadoop platform. So let's get started. On Scala IDE, we made a Maven project K-means renamed source main Java to source main Scala. Added Scala nature to our project, changed Scala library to 2.10. To link Spark and Hadoop, we have added these dependencies in pom.xml. Then we have made a Scala object K-means Algo in which our code is written. Before we start the code navigation, let's have a look at the dataset. We have bifurcated our dataset into two parts, train and test dataset. It is the train dataset, it is a test state dataset, and we have placed them into the input file directory, which is in our Hadoop file system. Let's have a look. See, these are the input files. We are importing data from these two input files and creating RDD here. Going ahead, we are parsing the imported data and mapping training dataset to a case class object type CC1. In the same way, we are mapping test dataset too. In the next step, we are converting these train and test data RDDs to the data frames using 2df function and printing them too. In the logs, we can see these training and predicted data snapshots. Now we are mapping these data frames to RDD with data to train K-means model. Training dataset vectors are creating from data frame using vectors.tens function. In this example, we are setting cluster value equals to 3 and number of iterations are 20. Here we are training our model with training data using train function. It has three parameters, train vector, number of clusters, number of iterations. Here we are calculating sum of squared errors using compute cost function and printing it. And going forward, we are saving all the metadata files in the local directory. And at last, we are converting our resultant RDD to the data frame. Now let's go to Cloudera VM and run our code. So our program ran successfully. This is the log. So we have collected all the useful items, results basically in one text file. Let's go through them. This is our training data snapshot. It is in the data frame format followed by predict data snapshot, which is also in data frame format. Here are our three clusters marked in the square brackets. Here's the squared sum of errors 2.1511. This is our final output vector. Underscore 1 indicates position of the element. These numbers are nothing but the cluster number which these data points belong to. Let's see the output directory made by this program in the local file structure. Here are yeah. It contains the metadata of the trained model and the data used in building this model. So here's the final output. Thanks for listening. Have a great day ahead.